Math 2414, improper integrals, infinite limits of integration, example 4. To get all the extra words, technically it should say determine if it converges or diverges. If it converges, find the value it converges to. But let's just jump right into it. We have the integral from negative infinity to positive infinity of 1 over x squared plus 9 dx. By definition, to approach an improper integral that has two infinite limits of integration, you must first split it into the sum of two integrals, each of which only has one infinite limit of integration. So our first move will be to split this integral at any number we want between negative infinity and infinity. I choose 0. You may choose something else if you like. We'll get the same answer if it converges. So our first integral will go from negative 1 to 0 of 1 over x squared plus 9, plus the second integral picks up at 0 and continues to infinity, 1 over x squared plus 9 dx. All right, so for both of these, we're going to have to evaluate the integral of 1 over x squared plus 9 dx. So before we set up the limits and everything, it might behoove us to actually integrate that as an indefinite integral first. Recall that the integral of 1 over x squared plus a squared dx is equal to 1 over a times arctangent of x over a plus c. So if we were to apply this rule to both of those as indefinite integrals, then because we have a 9 here, and because 9 is 3 squared, we have a 1/3 arctangent of x over 3 plus c as an indefinite integral. But as a definite integral, we won't use the plus c. And yeah, if you have limits of integration, don't write the plus c. I will count off for that each time. Okay, so let's attack both of these. And we have to do each one separately. So first, let's attack the integral from negative infinity to 0, 1 over x squared plus 9 dx. I'm going to write the way that it's actually shown in most books. When I've done these, I broke it into 2 steps. Change it to a t, take a limit. Truth be known, most books will say set up the limit of the integral with the t in the right place. The only problem with doing that is that now you have to drag the limit along every time you do an integral move. So it's actually easier to do the integral first and then import it into the limit, in my opinion. So why don't we actually do that first? Let's just worry about this integral. The integral from t to 0 of 1 over x squared plus 9 dx. Well, we already know the antiderivative. It's 1/3 arctangent of t over 3. Getting ahead of myself, x over 3, evaluated from t to 0. So 1/3 arctangent of 0 over 3, which is 0, minus 1/3 arctangent of t over 3, but arctangent of 0 is 0, so this definite integral is just equal to negative 1/3 arctangent of t over 3, because this is 0. All right. So now that we've done the proper integral for the first of our 2 improper integrals, then our second move is to take the limit as t approaches negative infinity of that answer, of negative 1/3 arctan negative t over 3. T over 3. This is where remembering the graph of arctangent comes in handy. Remember the graph of arctangent has 2 horizontal asymptotes. The one on top is at pi over 2, the one on the bottom is negative pi over 2. The graph starts low, hits the origin, goes up to the other asymptote. As we approach negative infinity, arctangent is approaching negative pi over 2. So this is going to approach, we have a negative 1/3. And you might be thinking, what about this 3 here? Well, guess what negative infinity divided by 3 is? It's still negative infinity. And because of the graph of arctangent, this goes to pi over 2. Negative 1/3 times pi over 2 is negative pi over 6. And now we have the value of the first of these two improper integrals. This integral converges to negative pi over 6. No, it does not. Negative 1/3, check. But this limit, as we go forever to the left, is not pi over 2, but negative pi over 2. This pi over 2 here should have had a negative on it. Shame on me. But you see how easy it is to make the most careless of mistakes. And now negative times negative is positive, so this is a positive pi over 6. Dang. I know why I put pi over 2, because at the last moment I changed this 9. It used to be a 1, and that used to be a pi over 2, but let's not worry about that. All right, so let's just review what happened since it was a train wreck there at the end. We split the improper integral with two infinite limits into the sum of two improper integrals by splitting it at 0. We attacked this one first by replacing the negative infinity with a t, doing the antiderivative according to this rule, evaluating it, this disappeared, and then we took the limit as t approached infinity of the antiderivative. And very carefully, when t approaches negative infinity, this arctangent approaches negative pi over 2. So we have negative 1/3 times negative pi over 2, which is positive pi over 6. All right, there's the first one. Now we got to do the other one. The other one is pretty much the same song and dance. It's just going from 0 to infinity. This guy. So using the same procedure, we're going to start by integrating from 0 to t. We're replacing the infinity with a t of 1 over x squared plus 9 dx. But that antiderivative is still 1/3 arctangent x over 3, and this is being evaluated from 0 to t. Well, this one's easy. If I put in the upper limit, I get 1/3 arctangent of t over 3 minus, but if I substitute the lower limit, I get 0 again. So we can just shut down the antiderivative here because this lower limit annihilated the antiderivative. In other words, because the lower limit caused this to be 0, that's why we can ignore it. All right, so our second move is to take the limit as t approaches whatever we replaced with t, which was infinity for the second integral. So limit as t approaches infinity of 1/3 arctangent of t over 3. Well, same song and dance, except we're on the right side of this graph. As t approaches infinity, so does t over 3. And so as we go forever to the right on this graph, our y values are approaching this horizontal asymptote. This limit is 1/3 times pi over 2, which is pi over 6. And now we're ready to wrap up this problem. Therefore, the integral from negative infinity to infinity of 1 over x squared plus 9 dx converges to pi over 6, the red one, plus pi over 6, the blue one, which is 2 pi over 6, common denominator, which reduces to pi over 3. Interesting. We have a graph that is unbounded on both sides. I haven't drawn the graph of this, but I can show you what it looks like. The graph of 1 over x squared plus 9, I'll just talk this out real quick. If I put in 0, I get 1/9, so it doesn't go very high off the ground. And it kind of looks like a bell curve. We could do some calculus 1 analysis to figure out the inflection points and all that jazz. But it should be pretty evident that as x approaches infinity or negative infinity, this collapses to 0, hence the horizontal asymptote. And what we're basically saying is, okay, the whole area under this thing is pi over 3.